Wow. I don't know if I get the bottom into that thing too. Whoop, whoop. Okay. So let me try again. Hurricane bands explain. Okay, wind speed, say it was 150 or you know, nice fast ones, and it was a nice big one that was 300 miles in diameter. You say he has a 40-foot eye just for fun. And at that speed, this rotation time on the outer circle is going to be 6 hours. So angular momentum law says that when you put that radius in half, it's got to have double the wind speed, and squaring that radius for you know, the inverse of the radius to have the rotational speed. So essentially what it's going to be doing is it should be going from angular momentum, and this is a law. I mean, once you push it in that far, that's how you're going to accelerate it. There's no ifs, ands, or buts, minus what's being subtracted from frictional forces, and or some other way maybe to escape, which is up. We'll get into that in a second. Okay, so at that, it should be doing 300 miles an hour at a diameter of 150 miles, okay, or radius, you know, of 75, bigger radius originally of 150. So it should be doing 300. It should be doing 4 times as many RPM, because you start to see why it cannot just travel as like a platter on a you know, record player or something like that, where, you know, the outside spinning at a certain speed, which is the fastest, and inside is a little slower, and in here they all rotate around together. It cannot happen. Okay, so you're adding additional pressure as it goes in. That's taking additional force that's counteracting that centripetal force. The centrifugal force comes from the speed of the air, the wind. Don't think there's something in there in the middle. There is nothing really, I think, that's important in the middle. There's no secret to find. You can take in a vacuum meter, that might be helpful. You can take in a Geiger counter. I don't think it's going to help you. Okay, I don't know, whatever instrument you want to find in. Really, all these forces are explained just by simple Newtonian physics. Okay, once you push it in there, it should be going 300. It probably can't, so, but it is going probably somewhat faster. Whatever, you get different rotational speeds, of course, and the thing begins to break up. It has to begin to break up at some point into bands. Okay, if you went into a radius of 37.5 miles, half again, your rotation time should be only 3 hours. Okay, whoops, what am I doing here? Okay, all right, so that's what I just did. Okay, if wind speed stays the same at R equals 75, rotation time 3 hours roughly, 1.5 hours at R equals 37.5, which would be that 75 mile radius, you know, down from your 150. So it can't stay together. Okay, angular, okay, so now if you went down to a quarter, if you went down to, well, I won't even work out what that figure is, but hey, there should be 600 miles an hour, right? And it should be 16 times the rotational, the RPMs. So, I mean, you can see that thing should be really going up, okay? Is there any 600 mile an hour winds in there? Huh? I don't know. Tell me, are there any 600 mile an hour winds in there? I don't think so. But, you know, so what it does, that's got to be slowed down by friction, which friction, the friction forces, if that was slowing the whole thing down to what it's really doing, I don't know how well that stuff is measured, but it would have to be generating it into heat. But there's also another thing it can be doing. It goes up, okay? In other words, you're putting all that pressure in, and believe me, it's cascading upwards, just like your water vortex is cascading downwards, when all of a sudden there's just nothing underneath it but air in that hole, and it can just go down, but it can't go straight down because there's this funny thing called friction and stuff that make it start doing this thing called spinning, which is just what happens when a vortex forms. It just always happens. There's no need to search for it in some mysterious place somewhere. That's what happens. Friction hits it, and your angular momentum properties hit it, your acceleration of your gravity hits it, or your pressure in this case, and it starts spinning, and you get this continued increasing pressure force that's pushing it up there. Okay? And so it starts just really going. And of course, anything that's coming down from way up in the stratosphere, I would suppose, down that eye into this so-called partial vacuum, is hitting that sidewall and is going and also circulating up. And I've seen some really good stuff about how they think there's roller bearings in there now. Vortexes from shears. Well, I don't know if that shear is actually there like they think. It sucks water up, and some of those things they're seeing in there now with whatever they got. I don't know where they can think they can see inside a hurricane, which is just great. Whatever it's really doing there, sucking up water. If there is a kind of a shear going on that creates another twirly that actually does have a place to go. I'm going to talk about wannabe vortexes where wind just spins because of a shear, and the difference between that, where what I call a true vortex, which is actually defined as what tornadoes, hurricanes, and all other wind vortexes do, that are real vortexes, and that's they're going up through a hole, okay, and they're being forced up through there by pressure. So, anyway, so it's going up, and that's what pushes that stuff up in an extremely powerful way, as you can see. And as we know, all right. So the rain bands. Okay, so you got cold air coming down, filling up, being a tailwind, etc., and it's bringing down clouds with it, rain clouds with it, and then it's putting them through the most massive ringer on Earth. Okay, I mean, this stuff is the biggest. Those old-fashioned washing machines with a ringer, and you just put them through there. That's what that is. You bring those clouds that are usually sitting probably just below the cold layer, and you bring that cold layer down through it, and you put it through this thing, and it just drops all this rain. Just boom, it just condenses, and it goes, and so you get most of your rain, of course, dropping in the outer rings of the hurricane, of course. Okay, makes sense? And so can I explain that? By the time it gets in there toward the center core, then it's lost most of its rain. Might be a lot of what you're feeling there is kick up from the water. I don't know. But whatever. It drops most of it rain, as they were trying to say, why does it do that? Well, that's why. Okay? So, it's going in there, and then the rain bands and non-rain bands, well, from the front, it's sucking in hot air, right? So, you get alternating bands of rain and not so much rain, because that's the hot air that really doesn't have those clouds in it, okay? And they're drier. So, I think I explained that, right? All right. So is there anything more I can explain about a hurricane? I mean, that's what I know about a hurricane so far, which granted is not as much as maybe people that study hurricanes all the time. There's a difference. So I got a theory. I got a theory that works. And I'm the only one that's saying, hey, get rid of the cold air barrier and let that situation stabilize with hot air going up and cold air coming down. And that's going to prevent your hurricanes in the area that you're able to do that in. And I'm the only one. I'm the first one, and I'm the only one that's saying that. I'm the only one that's come up with this theory that seems to be so compelling, if you will. So, I don't know. Prove it's not true. Good luck. All right. So the weathermen call that a temperature inversion. Okay. How do you fix a hurricane? If it can be done the same way as the tornadoes, okay, do a temperature inversion. Just got through saying that, right? Might call it a correction, huh? Because that's what wants to happen. We're just so used to seeing it, and maybe there is some benefits with it, and that's kind of what weathermen think, and they've been thinking that enough to where they don't understand that that's really not a stable situation, maybe. Okay? So, prevention, no direct attack on a hurricane or tornado. Thank you. No, thank you. Don't want to get involved. I'll shit my pants and run for the nearest basement if I ever see a tornado coming towards me at all. All right? It scares me that I want to go over there and see this and do this, but believe me, I'm scared of them. Okay? I don't know if you are. Okay? So what we're going to do is make the pin up, hot air penetrate the cold air barrier and go up and go away. And the cold air come down where we need it. And that will cool down the ocean without so much energy from some kind of a turbine pump or some insane stuff. All the other ideas are insane. Okay, this one, you're going to be using your best possible advantage in a direct way to stop what they are. Okay, problem, big job, impossible. Well, I don't know. I don't know. Sometimes I think it's going to be quite easy because it already wants to happen. All you got to do is give that little push over the cliff. Other times I think, well, that cold air barrier might be pretty resilient or something, and it might be hard to do. So I don't know. We got to try it, okay? I can't help but think that with all the stuff we got, that somehow we got either microwaves, guns big enough to do it somewhere, or we got, that mechanically through the right kind of airplane tactics, we could do it. And the pipes can't help it if we get around and actually decide to build them on beaches and or islands. Ships can do it. Ships can carry far bigger equipment, of course, anybody, obvious, right? So that might be a possibility. You can imagine a big ship, just kind of cruising back and forth up and down the Atlantic seaboard and then down to South America. Okay. No. All right, open up smaller vortices. See, I got the idea. Open up smaller vortices and relieve the pressure before it's built up and ready for a hurricane. Okay, that 200-mile or so swath. I kind of got dismayed a little bit by seeing a red laser in a small beam that's supposed to be the most powerful, one that was, I don't know, they were shooting at some tire on some boat, and it took a while for it to burn a tire. And he went up, man, if it's that pitiful. I don't know, maybe that laser would open up some holes, but if that's all we got, I'm a little bit worried about it. But, I really don't know. There's one at HARP that can punch holes in, punch the atmosphere up into space. It's so powerful. Now, we don't need one like that, or want one like that, but maybe there is something in between. I would hope so. ET. Strong enough even on battleships. Okay, chemical weapons strong enough, but not a good idea. They're too expensive and too dirty. Okay? Maybe wind silos on beaches would mitigate that. Temperature inversion. How far inland and out to sea, would that temperature inversion be? And would it be enough to stop the edge of a hurricane from just kind of superseding and still causing damage? Although it should help. Okay. Out to sea on islands, maybe not hit the coast. Okay, like in Caribbean, for instance, that would be the ideal place to put them to try to protect the whole, as much as possible, of the Caribbean and our coast along Louisiana, Texas, etc. Okay, maybe not hit the coast, at least as hard. Less fuel and pressure. All right. So, let me see what the time is. I'm going to talk to you in a second here. 3:50, I don't know. How long have I been doing this? I guess what I'm going to do, since I don't really remember what the time is I'm just going to, I'm sure you'd love to see my lovely face. The thing about, maybe I'll just, I'll try to focus that a little bit more. All right.